Hi, I'm Brady Hornberg.
Hi, I'm Jalen Nakagawa,
We're in Advanced Geometry Period 3.
and we did the exploration, the 7 bridges of Königsberg in Chapter 2.
And it took us about 5 hours. In some town in Russia that I can't pronounce, there are 2 islands, which are represented by the letters A and D. Then there are 2 cities on the sides, which are represented by C and B. There are these 7 bridges, which have been constructed. There was a big problem in this city, and they wanted to know if they could go from B, if they could travel all these bridges. They challenged one another to make a round trip over all 7 bridges, walking over each bridge once and only once before returning to the starting point. So this task was impossible for quite some time, but no one could really prove that it was not possible, and no one could prove that it was possible. So they contacted a mathematician named Leonard Euler about this problem. And he got back to him and said that it was impossible.
A collection of points connected by a path is called a network. When we say a network can be traveled, we mean that a network can be drawn with a pencil without lifting a pencil off the paper and without retracing any paths.
Step 1 is to try these networks and see which ones can be traveled and which ones are impossible to travel. So A is possible. B is also possible. C that way doesn't work. Let's see if anything else works. C is impossible. D is possible. E is impossible. F, that didn't work, is impossible. G is impossible because you can't get that without missing one of these. And H is clearly possible. Let's see if I works. Yep, very clearly you can do that one. J that didn't work. It is impossible. K oh, that didn't work. And I can't. K is impossible. L is possible. M is possible. N is possible. O that didn't work. O is impossible. P is possible.
So we discovered that A is possible, B is possible, D is possible, H is possible, I is possible, M is possible, and N is possible, and P is possible. The rest are impossible. They are impossible because we tried it and it did not work.
So step 2 says draw the river Pregol and the 2 islands shown on the first page of this exploration. Draw an 8th bridge so that you can travel over all the bridges exactly once if you start at point C and end at point B. So this is the river Pregol, and these are the 2 islands A and D. Alright, so as you can see, we had to try to make a new 8th bridge so we can start from C and end at point B. So the way we did it is we went from point C through bridge D, through E, up to G, back to C, through little c,
through big A, and then this is where we went through the new bridge right here, which I called H. So we go through H, then through bridge F, then through little b, back to point A, down to little a, and end at point B.
Okay, so step 3 is to draw the River Prigel and the 2 islands, and to see if you can draw an 8th bridge so that you can start and finish at the same point. It's basically the same as step 2, but you're just trying to start and finish at the same point. So in step 2, we found a lot of solutions. Like, you can start at B, go up, down, through the 8th bridge, around this, through, end in C. And so we were trying to just see if we could do that. Adding an 8th bridge and end in the same point. And we found no solutions. So we tried a lot of different things, and we couldn't find anything that seemed to work. You always end in a different point if you go through all the bridges.
So in step 4, Euler realized that it is the points of intersection that determine whether a network can be traveled. Each point of intersection is either odd or even. So it says, did you find any networks that could only have an odd point? Can you draw one? Try it. How about 3 odd points or 5 odd points? Can you create a network that has an odd number of odd points? Explain why or why not. All right, so we tried 1 point for this one, which works, is 1 point. 3 points for this one, 1, 2, 3, which works, yes. 5 points, 1, 2, 3, 4, 5, which works. And so when you try odd for odd, I just took the examples from the odd points over here and created it into a network. So this is 1, 2, 3, 4, 5, and it does not work because you end up with 10 points. And so this is 3, and this does not work because you end up with 6 points. So when you have an odd number of odd points, it does not work because a network cannot be traveled if you retrace it. So when you use an odd number for odd points, you are retracing it, which is not considered a network.
So step 5 was to see if we could come up with a conjecture to sum up all of our results. And we came up with a conjecture. A network can be traveled if it has an even number of odd points, and you start at one of the odd points and end at a different one. It is impossible to start and end at the same odd point.